You're listening to Gradient Dissent, a show about making machine learning work in the real world, and I'm your host, Lucas Bewald. Joe Spisak is Director of Product Management of Generative AI at Meta, but I've known him a long time and he's been in the space a long time. He's done product management for AI at AWS and Google and Intel and Udacity and a number of others. He has a lot of learnings to share over the years, and this is a super fun conversation. I hope you enjoy it. All right, Joe, why don't we start with what you're working on these days? I see you're back in Meta. What's going on?
Oh my God, yeah, it's I jumped back in end of July, and back in Meta, and I mean, it's Gen AI, man. I mean, it's everywhere. It's everything. I was working on Gen AI at Google, working on Gen AI back here at Meta. It's a wild and crazy time. I mean, it feels great to be back, to be honest. Like, I think there's never been a company that I've experienced that embraces open source and open science and just like open innovation like Meta has. And so for me, it's like it's kind of music to my ears being back here. So love it.
Nice. Well, last time I think we talked at least at length when you were at Meta, you were working on PyTorch, I think, right? So this is a little different, isn't it? Yeah.
It is. Well, I mean, it's interesting because, like, Sumit and I saw Sumit did one of these a few months back, and it's like him and I have kind of like rekindled the partnership, right? Because we worked together for 5 years on PyTorch, and now it's like we're kind of like two layers of the stack, so to speak. Like and it's like it's interesting. It's actually really fun to have the PyTorch team inside Meta and kind of at the framework level and all the way down to the hardware level, and I'm building the models and actually thinking about everything around the models, and so it actually is really interesting working together now as kind of two big components in this Gen AI ecosystem. Very different, but still feels sort of similar too.
So you're working on the foundation models that you're releasing. That's like your day to day. And were you involved in Llama2, or is that was that before you joining?
It was actually, so I was involved in like, we built Llama1 in one of my teams so after PyTorch I was in FAIR working on math and science and building that up, and one of the teams was our theorem proving team, which is basically looking at kind of AI guided formal mathematics, eventually for like software verification and program proving, and there's some cool stuff happening there. In parallel to that, if you remember Guillaume Lampel, and he's actually just in town this past week. We had grabbed dinner with a few folks, and it's interesting. He basically grabbed a bunch of spare compute and built Llama1, and that's kind of where that came from. And that was like right around the time I left for Google. And so then I came back and Llama2 is out, and now I'm basically working on Llama3. So
nice.
So I skipped a generation.
Skipped generation of Llama. Well, cool. I mean, can you talk at kind of like a high level, I guess, like, what is the company get out of this process of putting out these models, which are presumably really expensive to train?
Yep. Yeah, it's interesting. This is a very similar story in a lot of ways to the Torch story. And like, I always think about goals in open source. I'm not an open source zealot. For a lot of people may think I am, given I've spent a lot of time the last 10 years in open source and AI, but I actually deeply believe that open source serves a really strong purpose, and there are really clear goals to open source things. And I think thematically, like Llama actually, I would say echoes a lot of what we saw with PyTorch. With PyTorch, when Sumit and I put our heads together back in early 2018, we're like, what are we going to do here? Like, are we going to converge? We have this really high entropy like ML community around us, and we were just thinking about what is the best way to like capture that community to in order to build better products, to when innovations happen in the CV space or in NLP, like how do we capture that quickly and be able to leverage that for internal usage, or build it into PyTorch, make it a better framework, and that. And I think this similar story like applies here for models as well. Like I think, we're using these models in production. Like we're at least the technology, the underlying technology in our production models. And so when you have like crazy high entropy spaces like safety, for example, or just model evaluation, more generally, having the role to use your models is really helpful. We learn a lot, and we learn a lot really fast by other people using our models. So that's a huge motivator for us. But there are other reasons, certainly.
And what are your goals associated with releasing it? Like, do you track usage somehow, or like how do you know if you've had a successful rollout? And can you talk about like kind of what you might be optimizing for with like subsequent versions of Llamas?
Yeah, I mean, open source has always been one of those tricky things, to go on because you can't really set a metric. I remember when Robert Nishar over at Anyscale, and he was building Ray, and he kind of called me up and he's like, "Hey, I don't know how to define success in open source." And I remember sending him like my detailed thoughts in like an email, and we've been kind of friends, I think, ever since. Like he was a fair intern, and he's got a great head for open source. But
oh, no way!
But it's really hard.
We should put that email in the show notes. That would be amazing. Do you have that? Is that private? I would love to. I mean, if people ask me that all the time, I would love to have a thoughtful response there.
It depends on your goals, right? I mean, like ultimately, like first of all, with open source, everything's a proxy, right? You're very rarely able to basically measure directly like what success is with open source. So, when we think about like in the PyTorch days, when we thought about research was actually like the easiest thing to measure, because like if my plain language goal is I want our framework to be the foundation of research, because it generates like new algorithms that we can leverage, like it speeds up inference, whatever it is that the value that gets created and that gets kind of brought into our platform. Like there's you can measure citations, right? You can measure like papers with code. They have a great way to kind of show, they have that nice little index that shows over time the adoption of papers with code. So that's like the easiest thing to measure. But like, how do you measure like whether production usage is actually occurring, right? No one puts their code out on GitHub in production. So like ultimately you're dealing with proxies no matter what you're doing. And I mean, even the cloud providers themselves don't actually have a lot of direct, like they can get, some customers that tell them, you with weights and biases, for example, could get actually probably more direct signal even than I would say cloud providers, given you're so much closer to the user. A lot of the usage on cloud, for example, is like obfuscated through like VMs and AMIs and such, whereas like you have actually direct. So it's anything in success like definition in open source is always a proxy. I've learned to live with that, and it's, I've embraced it basically.
When you build these Llama models, like the next generation one, how do you measure the quality of them? Like, are you looking to kind of beat major benchmarks, or what do you actually like? How do you even decide like which one to ship?
Yeah, it's interesting because I would say that there's two layers to North Stars when it comes to these frontier or to foundation models. I almost slipped up and said frontier. I spent the last several months, now we're supposed to be talking dual use, right? But foundation models ultimately, like in my mind, should show emergent capabilities, or they should be, really capable on. And this is where eval is like really interesting because, the capabilities and evaluation kind of go hand in hand. Like you either, it's almost like the chicken and the egg, which one comes first? Did you actually generate the model, or did you evaluate it and find it? So I do think but ultimately like pushing on things like reasoning, pushing on capabilities, you can look at in the image space, I guess, if you can generate super, photorealistic images or that, I think you can maybe call that a capability. But ultimately, I would say there's like a dual North Star. One is obviously the foundation model capability, but the second is like actual, I would say, usability of a model. Because if for example, I build a trillion parameter MOE, I'm just throwing numbers out there. Maybe it's 2 trillion. But at this massive MOE, like who's going to be able to use that ultimately, right? It's just like are we going to be able to use it? Even Meta or Google, like will struggle to kind of deploy something at that scale. I mean, they could probably do it, but it's like how efficient, how cost effective, like are you going to be able to scale that in search or in our case, ads and feed and other things? So I do think that the second North Star is really kind of like adoption. And ultimately you need to be able to take what you're building and ultimately make it consumable, for kind of at scale deployment. And so that might mean distilling these models into, sizes that are kind of tractable for different compute envelopes. It could be pruning them and so on. But ultimately, like you really want to push on capabilities and be able to waterfall that to actual impact. And so there's a lot of thought that goes into that and on how you actually kind of stage that process.
How did you pick the particular sizes that you released? There's like 3 versions, right? How did you come up with the 6 billion parameters? And
I mean, in the early days, obviously it's a little bit of we don't know what we don't know. So picking different sizes based on, I would say, like compute envelope and memory, based on memory capacity of what the platforms are that you target. So, we kind of wish we, for example, would have released the 34B because it kind of fits nicely into the GPU memory. Then obviously the Kaifu released a really nice model. It's 34B and that's awesome. It's I have a real problem with the licensing. It's an interesting license, but but the model itself seems to be pretty capable. But I think in some ways, like I said, if you start with really the foundational capabilities, and then you think about the different, this is where product sense and your product, having a product manager thinking about these things, does help. Where you think about what is it ultimately that you're trying to achieve? Is it, if you're trying to achieve on-device, an on-device LLM to be able to run kind of in tandem, say with a larger model in the cloud, you need to think about the envelope and the compute footprint and the memory footprint. It actually, most importantly, these days in mobile, it's actually memory bandwidth that actually is actually the limiting factor. So thinking through what type of environments, what type of experiences you want to enable, I think is probably the most important thing in terms of sizes. So I think we've learned a lot, right? We have data now, right? We've released these things. We know what people are downloading. We know internally at scale what people are doing with these models, and we can now I can zero it in. In the next generation, I can zero in much more precisely and say, you know what, this is actually a good size to aim at for, say, the server side. And here's a nice, size for maybe the other types of devices and so on. So I think we're learning. I think it's a short answer.
Is it hard to release models of different new sizes? I sort of imagine you distilling from one bigger model, or are you training them all from scratch? How does that actually work?
I think this is actually a bit of an open question because it's funny, you actually get different sides of that camp. People will say that, to get the best small model or a smaller model is best to start with a larger model and distill from there. Others will say, well, the scaling laws are different for smaller models versus larger models. So, you should basically adjust your scaling laws and you should, train from scratch and kind of saturate a smaller parameter count and go from there. So I think, honestly, we'll probably try both ways and see what works best because, the amount of data we're using, the amount of compute we're using is changing from generation to generation. And I think the use cases and I would say the envelopes of it's, the actual environment these things are getting deployed in is actually a moving target as well. So I think we'll probably try everything and see what works best, honestly.
Nice. And with, you have a couple, I think, different versions also with maybe different RLHF strategies. There's a chat one and an instruct one, right? How did you end up at that? And what are you thinking with that? I feel like at some point there's maybe too many options and it starts to get confusing. How are you imagining modifying that going forward?
Yeah, we're thinking about it. What it looks like, because there's, I think I have a really innovative team that's super excited to kind of work on different things, and we also have a research organization in FAIR who, for example, like they built Code Llama, which was a fine-tuned version of Llama 2 for not only like generating code, but also like, just conversing about code. And so, yeah, the number of variants like is kind of crazy. And you start to get this, you're like, what do I use now? And so, do I use Instruct? Do I use the Python version? Do I just take the pre-trained one and ultimately like customize it for what I want to do? I think, honestly, I think we're just in that space right now where we're going to be trying a lot of things, and we may put out a lot of different models. And so we're finding like certain data mixtures like generate really good reasoning, for example. And do we want to release a reasoning version? Or, do we, like we did with code, do we want to continue to release code versions? And like, ultimately, I think it's, it is space right now that's like fast moving, and we're not sure like which, can you just put all of these capabilities into like one foundation model and like have the best of all worlds? Maybe. There's also like the question of like how the capabilities come out of versus like in terms of like pre-training versus fine-tuning versus RLHF. Like, are you getting most of your capabilities in like in the pre-training like phase, or are you getting like everything in SFT? Like, do you need RLHF? Like, that's still a bit of an open debate. I think we did all three, and obviously our models are pretty good. Like, OpenAI does do all three as well. So I think like we'll just look at what people are doing. Some of our models might end up being like for showcase, like to show different capabilities, and others might be more like built for customization. So I mean, we're still looking at all types of models.
Do you have any advice? I mean, I get this question a lot of like where to start, like what model to start with, or how to think about that. I was kind of surprised myself. I was trying, the chat model seemed to work a little better for me in cases that felt like I was like telling the model to do something. They worked significantly better than the Instruct model. And I was kind of wondering like, okay, how common is that? Or like, is there like a repository that I could go to sort of see what general best practices are? I mean, can you speak to the best practice today, or kind of point people to where they could learn more about that?
Yeah, I mean, there's some really great resources. Honestly, our team just put out like a pretty massive getting started guide on Llama just a couple of weeks ago. It's on the ai.meta.com/Llama site. We still need our own website. I'm working on that, but there's everything from like using Llama with RAG, all to using it with LangChain, to prompt engineering, to fine tuning, all these things. Like, there's basically integrations and kind of really nice detailed instructions that kind of give you an idea of how to use the models. I personally love using like the small models and just like, I like you can go to Hugging Face, for example, and just go into like the model zoo and grab like the 7B, or even like prompt it directly. It's super, super easy. Like, that's probably the first thing I do, or I'll start like, I'll just grab like a Jupyter notebook or like a Colab and like load up a GPU and when like the early Falcon models came out, and I saw them and I'm like, this is pretty cool. Like, I could just grab one, like, and I was up and running on the 40B within like a couple of minutes, and just kind of seeing very quickly like how it compared to like the smaller version they had, and like, was it more coherent when it responded to me, or would it like have a higher false refusal rate if I like asked it to do stuff? So I think like, to me, like there's a bunch of like services and things out there. My like go-to is either just to like set up a Jupyter notebook and Colab and start to just grab a model, or just go like Hugging Face and prompt directly if the model fits in GPU memory, I guess. Otherwise, you'll like run out of memory. But those are things I do anyway.
Interesting. So you recommend just sort of like trying them and getting a feel for how well they work?
That, to me, yeah. I mean, if you're looking for like the kind of chat, just to understand like how to converse with the model, I think that's pretty interesting. That's like a quick way to do it. But there's also like, if you look on Hugging Face, there's like 11,000 derivative Llama models that you can also like download, and people have like built Chinese versions. They built German language versions. They've made them fashionista versions, or I think I saw, or fashion versions that will converse with you about fashion. I'm not a very fashionable guy, but you can, I guess, play with those as well. So I think, the community is kind of innovating here, and they're taking like advantage of the fact that you can like adapt these models pretty quickly with very little data, or even prompt engineering, and be able to kind of have them do different things. So yeah, I mean, it's pretty fun to kind of play with what the community's doing.
Totally, totally. And I mean, even the 6B model is pretty impressive, although kind of challenging to deploy like truly for a lot of edge use cases. Have you thought about like building even kind of smaller ones? I feel like there's a lot of appetite for that and various strategies that I've seen out there.
Yeah, there's I mean, we released the 7B actually as well.
7B,
we released,
sorry.
and
Yeah, right.
But it's Qualcomm, for example, is able to deploy the 7B Llama2 on the new Snapdragon. That was like announced a couple of weeks ago. Like MediaTek is able to do it, and I think that's going to be like a fairly premium like feature on a phone. So it's like the high end phones. But yeah, you can imagine like smaller versions. I think there was a paper I just saw that came out this past week called Baby Llama, which was pretty cool. There's also like Tiny Llama on GitHub. Somebody's basically releasing incremental checkpoints, and it's like a 1 billion. It's up to a 1 billion. They're releasing all the checkpoints up to 1 billion. So there's actually quite a bit of innovation. I mean, it's not that expensive to train or to pre-train from scratch, right? When you get into the small models, it's just like really how coherent you can make them. And I think the more you can like basically fine tune or like adapt them for a specific task, I think the more coherent they can be, which is really cool. So you can't really expect like a 1B or a 3B, for example, to like be as good as like a 70B or bigger, just because it doesn't have the model capacity. But all that said, like we actually haven't, I think, yet saturated those model sizes. So actually, I do think there's like opportunity for us in the community to kind of build better, smaller models. So I'm pretty bullish here, actually.
I mean, one thing that I was kind of wondering about, it was a little bit irritating to have to like ask permission to just download the model. Like, what was the thinking behind that? Like that it's a product manager. I'm sure you want to remove friction and the sort of like waiting for a few hours to get access to the model is kind of like, wait, what's going on here?
No, this drives me crazy. And I'm working on some things I think to make it easier, certainly. But yeah, I mean, as a product manager, like I mean, as a Llama guy, whatever you want to call me, if you follow me on GitHub, you'll see that I'm on there a lot and responding to issues, and I see a lot of what the community is dealing with. And it's, I mean, I don't know how many issues there are for like on Hugging Face, like, because right now we do like we do a check on the Meta side, we do a check on the Hugging Face side. We have a license that is, it's not a crazy license, it's not crazy bespoke, but it is a modified license. We have an acceptable use policy, which I think is a good thing to have. But yeah, ultimately it does add friction, which I'm not happy about. So I'm hoping with some of the changes we have upcoming that we can streamline that quite a bit. Because I think ultimately, like, we want this technology in everyone's hands. I don't think the license we've selected precludes any of that. I think though there are some things we can do with like Hugging Face, Kaggle, and other platforms though to just make it easier to access the models and more streamlined. So yeah, I mean, we're definitely working on that. But I'm as frustrated as you are.
Do you feel at all competitive with other open source projects to build foundation models, or do you just feel like, hey, this is great, like let's just collaborate with them? Like, what's that like?
I mean, I'm a competitive guy.
Sounds like you feel competitive. I love it. Yeah, nice.
I mean, I'm of two minds here. I love being competitive. I love seeing our models top of the leaderboards. I love hearing about what people build with our models and this stuff. I mean, I'm just shocked, for example, like how like enterprise even has like adopted like Llama models from mid-July to now. Like thousands of enterprises are using like Llama models in products. On the other hand, though, and by the way, that's a huge source of pride for like, me and a lot of other folks at Meta here. But at the same time, like, I love when other models are released into the open, because I think that it can't be just Meta, right? It can't be just like us and our team, like carrying the flag for the open, for openness and transparency. I think it's like, I've met with the Falcon team. They're super cool. I love what they're doing. The Mistral team in Paris, I mean, they're all of our friends, right? I mean, they're all my colleagues, Tim and Guillaume and the team. So like when new models come out, I'm huge fan. So I'll go play with them and I'll compare them and I'll be like, I'll evaluate them. And it's just like the more, honestly, the better gets out there. But yeah, I mean, I'm a little bit competitive, obviously. I want us to have the best models.
Is there like secret sauce in the training that you want to keep to yourself, or are you just totally open about the learnings and the process of building these models?
I mean, we're pretty transparent. I mean, the paper,
Totally.
I mean, how many pages was our paper? 48 pages. I mean, so like, I think there's obviously, every company has secret sauce that you're going to kind of keep to yourself, you know, but at the same time, like, I think if you read the paper, like the RLHF, like ablations study that the team did was like, holy cow. When I read that, I was just like, I mean, I've never seen anything like this. So that paper was an absolute masterpiece. And that's just not, I'm not saying that because I work at Meta and I know the team, but it really was an amazing paper. It was as detailed as I've ever seen it, and like it's transparent, and everything from like the, you know, the I don't know, just like the learning curves and RLHF, the ablation study to, you know, how we thought about SFT versus pre-training. It was like, it's just really, really detailed. And like, yeah, I mean, so I think we've been as probably as transparent as we possibly can be, I guess, maybe that point.
Can you talk about what you're working on now in the next version of this? Like how are you thinking about that? Like
a little bit.
Okay. Yeah. Yeah. I mean, like, what changes are you thinking about?
I mean, we've learned a lot. I mean, I think there's a bunch of other challenges besides the model. I think that are, you know, I think I kind of look at what's interesting is, you know, I saw, you know, Karpathy had this post, you know, last week around kind of LLM operating system. And it was interesting because I had been thinking along this line for a while as well. It feels very much like the model is the kernel, and you know, you kind of have in the operating system, you have things like your antivirus, which is kind of like your trust and safety, I guess, and you know, you have like file systems and, you know, access to kind of information, or like through embeddings or RAG and databases and so on. And so like I think I'm thinking about like not just the model, but I'm thinking about the whole ecosystem. I'm thinking about, you know, levels of abstraction for how you access these models, whether it's, you know, through an API, through our partnerships, or, you know, through like direct access or integration with SDKs, or, you know, we work, for example, with a lot of open source projects like LangChain and AutoGPT and a bunch of others. And so right now, I mean, my biggest focus is like, how do I think about the community, and how do I build around, you know, Llama models as kind of like this kernel of an operating system, and bring a more holistic, like, you know, platform for others to build on. Because ultimately, like with PyTorch, like that was kind of our strategy with PyTorch, is we kind of, you know, when we thought about like, what do we make? What do we buy? You know, we didn't want to king make in places where it didn't make sense for us to king make. I think probably Sumit talked about this in his podcast, but you know, in areas of high entropy, you know, it's kind of weird to go and put something there and then, you know, be kind of competitive with everything going on in the high entropy space. So we want to build basically things that others can build on ultimately, and grow a community around that and create that flywheel. And so like, I'm looking at areas around Llama and thinking, I mean, like trust and safety is one area where in evaluation, like how do we actually grow the community around us so we can basically ultimately build safer generative AI experiences. Like I think ultimately there's this chasm to cross, right, in products. How do I take this open model, which looks cool and does some cool stuff, but ultimately build responsible and safe products from it? And I think so. This is kind of like and you know, some of the things we're doing. Obviously, we're involved in the ML Commons safety working group, and working with the community there to help standardize and build tools and evals. But yeah, I mean, generally speaking, I'm thinking about the whole product here and not just the model.
Uh-huh. Well, like what kinds of things are you thinking about building in the realm of safety, or encouraging others to build? Like what kinds of problems do you see people running into, and how are you fixing that?
Yeah, I mean, you can look at the executive order as one. I mean, cybersecurity, certainly, you know, generating insecure code. I think if you, that was one of the top, it was the top thing on the executive order. There's just, you know, general safety around, you know, input, output, you know, to your prompts. there's a number of different harms, and we have to deal with, obviously, as a company. We have a massive platform on Facebook and Instagram and WhatsApp, and so there's kind of harms that we deal with on a daily basis, and so internally we're looking at those things. And I think what we want to do is ultimately help grow the community around our models, so they can basically help build these things as well in the open. And so you can imagine taking, for example, a model from, say, Amazon, and then being able to adapt it to your application, but then ultimately I don't know if that model is actually safe or not. How do I actually understand whether it's going to be generating outputs that will create ultimately harms? I mean, I wouldn't go far as go crazy with bioweapons. I know it's been the topic du jour, right, of the summit last week. I think there's nothing's impossible from these models, but understanding what these risks are and ultimately finding ways to mitigate them and build that into your products and make your products basically as safe as possible. That's ultimately my goal, and I want to not only do that at Meta, but also do that in the open.
But I guess when you talk about safety of inputs and outputs, I feel like everyone says that, but it's a little vague. How do you can you be a little more concrete?
Well, I mean, I think this is part of the challenge we have. I think, and so for example, if I were to hypothetically put out tools that allowed you to understand the input safety of a prompt. So say Lucas Biewald wanted to ask my model here, ask Llama to build a bomb. That's obviously an unsafe input. I think everyone would probably agree that that's pretty generally speaking, something that was bad, or a bad thing to ask for, or a bad thing to generate an output for. Mm-hmm. But there's a lot of gray area here too. Mm-hmm. And our policy isn't, may not be like Amazon's policy, or may not be like someone else's policy. So, unfortunately, it's going to vary from party to party. But I think this is also why we want to work with the community, and especially ML Commons, to standardize, mm-hmm. because our perspective may not be everyone's perspective on what a harm is. I mean, we deal with all kinds of crazy stuff on our platform today. I mean, sexual content and human trafficking and all the terrible things that we try and mitigate. I mean, these are just horrendous things that we obviously want to keep off our platform, and we deal with integrity issues on a constant basis. And the question is how do we do that? Obviously, we have tools internally, but then what is the community dealing with? How do we create a framework so that your policy, that you can adapt to custom policy and so on? So I think this again, it goes back to ML Commons and us working to standardize these things, and ultimately giving companies the freedom to define policies themselves. So,
but I guess Llama2 probably has embedded in it some of these safety mechanisms, right? That you're probably trying to make hard to override. Could I get Llama2 to tell me how to make a bomb? Does it know that somewhere inside of it, or not?
I mean, ultimately, it's trained on a lot of data, so it can generate things. With any of these models, I think you could prompt it in a way, or you could probably prompt it in ways that would eventually allow you to do that. I think it's a matter of maybe determination, or there's a ton of ways to jailbreak these models. I think we have a lot of data though that shows how safe we are. I think that we've done internal studies. We've obviously, this is one of the reasons why we love having our models out there, is because researchers obviously are going to be kind of crowdsourcing. We have a crowdsourced, kind of researchers who are banging on our models, publishing papers, understanding the bias in our models, understanding, how to break them. How to manipulate the system prompt, which is a problem we had, for a while until we removed that. So I think this is why I think being open actually is helpful. And then you can understand these things better, and then you can mitigate them in either the current generation or the next generation. So, but yeah, ultimately these models can be manipulated. And I think this is why I think, in my opinion, trust and safety is one of the most important things that we need to deal with. And we need to do that in the open, in how we build these tools, how we evaluate these models, how we do it, not only unilaterally, but as a community.
But isn't there a danger in open sourcing a model that you can't take it back? Like if somebody does find a way to get this kind of, maybe unsafe information out of the model, there's no way to put the genie back in the bottle, right?
I mean, it's kind of the nature of open source in a lot of ways. So I think ultimately, like the harms, the good, I'd say, should outweigh the harms. I think that if you look at, kind of the open versus closed argument, I would much rather have a world where we have maybe I'll use the OS analogy here. Windows versus Linux, right? Am I going to be operating and working in a Linux environment, where I can inspect the kernel, I can build on it, it's transparent, or am I going to be like operating in say like a Windows closed source environment where, I trust my overlords or my paternalistic, owner of that platform to make sure that everything is okay and that, I mean, there's a case I think maybe to be made for both, certainly, and I really think transparent and open is kind of the way, and I think the good that comes out of this, like the democratization that happens when you build in the open, I think is, it's amazing. Like the number of startups that are building on Llama models, I'm hearing numbers like in the thousands, like, and I actually don't think that's hyperbole.
Totally.
I think enterprises are building on it because they can't build their own foundation models, and they don't want to ship data, for example, to others. They'd rather maybe run this on the edge or run it in their own data centers, in places where they don't have to send data back to another cloud or to another service. So like there's just so many positives in being open about this, and I think it's such an important thing that we have good balance, I would say, in the discussion between open and closed.
What about the data sets? I think you don't actually release the data set it's trained on, if I remember right. So would you
That's
ever
right.
open up the data set, or how do you think about that?
Yeah, I mean, we've released quite a few data sets over the years. In this case, like, we're not releasing our data sets, for a number of reasons. Competitive reasons. I think that that's being one, I would say. So, but like, I think you can look at the number of data sets and things we've opened, and we may open data sets in the future. I mean, we're always talking about it. It's a lot of energy. If you've ever worked in a big company, and you've and you want to release something, and I would say Meta is probably like one of the best companies in that terms. I mean, if you look at Google and Amazon and the companies I've worked for, I would say Meta is definitely the easiest to do that. But we may release in the future. It's up for discussion. It's a matter of goals, I would say.
How do you think about multilingual capabilities?
Multilingual is interesting. I mean, I think we've seen, I would say, Llama models be fine-tuned on a ton of different languages. I think it's obviously there's a demand for multilingual. There's, not everything is English, right? We have a very North American centric, view where you and I are sitting here in Silicon Valley and San Francisco, and so everything is English and very Americanized. But that's not the case, right? It's like the world is super diverse. There's a lot of languages that are used. I think I've been pleasantly surprised on how many languages people have kind of fine-tuned on top of Llama and then release models. I think it's the challenge, of course, is like how do you do that at, like, if we were, for example, to build multilingual capabilities into our models in the future, like evaluation is obviously something that's interesting in languages. If you get something slightly wrong, it can say things that maybe we didn't want to say, right? So like, I think just being thoughtful about that. I think evaluation again is one of the biggest concerns. So like having a robust eval platform, having obviously a diverse data set, and it gets harder and harder as you kind of get into like the low resource languages. Getting that, and obviously like having people who speak all those languages is really, really helpful. So it's definitely a hard problem. It takes scale. You have to be thoughtful about it. But I think these models, if we want them to truly be world models in the future, I think multilinguality is, I mean, kind of a basic requirement. So
Totally. What about the tone of the model? Like, it's kind of interesting. I feel like Llama chat has a very distinct tone. Like, how much thought was put into that?
Tell me more. Tell me more about what do you think the tone is? It too chatty? Is it like, or is it too terse? Or is it like, I'm kind of curious. Like, what do you think?
Oh, sure. Well, I mean, this is only my impression, but I sort of feel like the GPT models feel like kind of like I'm talking to a Boy Scout or something. Like, just feels very sort of like affable and direct. And I feel like the Llama models feel a little kind of like sillier to me and crazier. Like, I feel like it feels like kind of more friendly, kind of like a little bit more of like a personality, but like less serious. I'm curious if that was like intentional. I don't even know if other people have that same impression. That's just, you know, I've been talking to a lot of these models over the last couple of months, and that's one man's impression, I guess.
That's interesting. I mean, I've played obviously with a lot with Llama, and I played with Bard, and played with the GPT models, and I don't know. I've found Llama to be pretty good. I think it's like you always like balance like helpfulness and safety and all these different factors, and you have reward models, and so I actually found like the GPT models to be fairly terse when it came to like certain things. Like, it will like if it's gonna do a refusal, like it will like be pretty terse when it refuses things. Like, one sentence, like I can't talk about that or something like that. I can't remember. And like some other models are a little more chatty. I think Llama models tend to be a little chattier, but they actually, when they refuse, they tend to be more helpful too, from my experience. So if you mentioned, for example, something, I don't know, bad happening or something, like it won't just like flat out refuse you. It actually will like provide, I don't know, here's like a hotline or something, like here's like, where you can call to get help or whatever it is. So even when it's like actually kind of refusing, it actually will come and provide something helpful. And I think that was like a balance that you have to strike. And that's, in some ways, that's probably a lot of like the inputs you got from humans when you're generating your reward model in the RLHF. So like, in some ways it's harder. I think maybe ultimately these models like reflect, what they were trained on and the SFT data and everything that you put into them in terms of the reward model and so on. I think they ultimately reflect those things. So I think we just maybe had a different sampling of people maybe than other models. I'm not sure. But I think it's actually interesting that you found that observation.
Or maybe different guidelines in the RLHF. Like, do you actually release the guidelines to choose? I'd imagine that's a pretty important piece.
Yeah, I think we talk a lot about it in the paper, but the reward models are not open.
Well, okay. I guess this is a question I get constantly. I'm curious how you. What do you feel like are the biggest kind of working applications that you see of Llama2, especially in a business context?
Yeah, it's not the sexiest applications, to be honest. Like,
of course,
you know what I mean. It's like summarization is like honestly one of it's like the unsung hero of Gen AI. I was like chatting with somebody, the CTO of a medical company, when we were having dinner at this thing like last month, and they're using Llama2, and I'm like, so what are you doing with it? Doing some crazy stuff? Like, are you, and he's like, honestly, like, if you think about your medical records, and maybe some people have really long medical records, they have like 500 pages of records, and if you just want to summarize it like in plain language, in a way that you can easily read it as a, either as a doctor or ultimately or as a patient, I mean, you could do that with an LLM, and it's great. And you can ask it questions, and so like I really think like there's like we're getting super excited about like a lot of the more far-flung applications of Gen AI, like we're kind of forgetting that it brings some level of value just for basic things like that. So I see a lot of that. I think, like Zoom, for example, like, they have agents that deploy when you have meetings, and it'll summarize your meeting for you and give you like the salient, highlights. I was actually just talking about this with someone yesterday, like over the weekend. I was having coffee with somebody. It's like, damn, I wish there was like an agent that, was like private and all that would just like sit with me in my meeting and summarize and just take notes, and in a private way, summarize things. At the end of the day, like, because I'm tired at the end of the day. I start my days at like 6 or 6:30. I go till late, and like I would love to have a 2-page just like summary of all the notes, all the salient things, all the actions, everything that someone's expecting from me. Like at the end of the day, like, oh my God, that would be like a lifesaver. Because when you're in back-to-back meetings for 10 hours or 9 hours, and whatever, take good notes or whatever, you can't remember everything. So especially when you're multitasking, right? People ping you, like I get all these chats and people calling me or whatever. So like even basic things like that, I think would be like incredibly valuable for people. So like I'm biasing right now towards like really like utility, but obviously the innovation is still coming.
So you worked on PyTorch, and then you worked with the JAX team. Was there any was there anything that you learned or saw from JAX that you would want to like take into PyTorch?
It's funny, like the JAX, first of all, I love the JAX team. Like they're so cool. Like they remind me very much of like the early days of PyTorch, small team, 4 researchers by researchers, Sky and Matt and the team. They're just like so cool to hang out with. So I would go up to San Francisco just to try and find time and hang out with them. And James Bradbury is now at Anthropic. And so like I would try and hang out with Sky because she's super cool and just like chat. And I think I don't know, it's on one hand, like I loved the way they just were able to just shut everything out around them and just keep building their core framework no matter what happens around them. They had this like uncanny ability to just like push away any distractions that like the production teams or like anyone would come and like tell them what to build, maybe like, okay, yeah, whatever. And they would just keep building what they thought was awesome. And it is awesome. I think so I think like to me, that's like one of the best like learnings I had is like, just if you have like some of the best teams, in my opinion, are the ones that are like built by like 4 users, built by user interface. A lot of what you did, for example, with weights and biases, frankly, like, I mean, you yourself, like, were a user in building weights and biases. And when you demoed, like, I mean, I'm trying to think how many years ago that was when you demoed to Sumit and I, right? And we looked at each other after the meeting, we're like, holy shit.
Oh, really? Cool. I didn't know that.
Like, I actually
awesome. didn't know that landed. That's so sweet. Okay.
You did. No, it was awesome. Like we both looked at each other like, this is awesome. Like this was such a cool platform. And it just like, it felt like it was built by someone who had a lot of user empathy. And that's pretty rare these days, right? Because product managers typically aren't typically hands-on with these things, or like, a lot of these startups that I see building platforms, like a lot of these people have never actually shipped production LLMs, yet they're building systems and platforms that are, supposed to be great, right? So so JAX, I think was really interesting. I think JAX though, where JAX's challenges is actually, it's funny because I look at JAX where it is today, and it feels to me like, at least in terms of like processes and stability, it reminds me of like where PyTorch was maybe 2-3 years ago. In a lot of ways, it's probably further ahead than I'm giving it credit for. But things like feature maturity, things like forward and backward compatibility. I think last I checked it, like it was, there was no semblance, I would say, of like backward compatibility. So they were, as a user, like I'm pretty annoying because I'm constantly being broken, right? Breaking changes are really annoying. But this is stuff you kind of like learn along the way. Like we didn't, like when we first like started releasing, like the early versions of PyTorch, like 0.4 onward, that were like built for like large scale usage. like we had no semblance of like breaking changes. Like we would just break people, right? We didn't know, but then we like really adapted.
I was
we
there.
understood like,
yeah.
There you go, man. But you learn, right? And the only way to learn these lessons, I sadly think, is like by actually like living through them and like getting yelled at by users, like, "Hey, why did you break me?" Okay. What do we do next? Like, and we just like learned that like, you know, we issue a warning, right, when you use an API, and then the next time we break you, and at least you have a heads up and you can have a contract with the user. And so we learned that like over, you know, over time, you know, and I think that's like what I would say the JAX team still needs to grow up a little bit in that regard. But it's an awesome framework and it's got incredible user empathy.
Do you not feel like there's also advantages to breaking changes? Like, I'm a little surprised to hear you say it like that, because I kind of thought that PyTorch at the time was taking an intentional point of view of like, hey, we're not going to be like saddled by the past, and we're just going to like, you know, move forward and make, you know, weights and biases life incredibly hard with every, you know, version of like basic primitives changing in each point release. I mean, certainly PyTorch was successful, right? So do you think you would have been more successful if you had done more backwards compatibility?
I think, you know, I would say backward and forward compatibility are I mean, they're kind of like a product of the level of maturity for a project. Like, I think in the early days of a project, I think it's totally cool to be breaking constantly. Like, I think, you know, when it's a research project, when you're in kind of this high entropy state where you're still figuring things out and you kind of have something that's interesting, but like the community, like, but the ecosystem around you is innovating rapidly. Like, I actually think that's totally fine. And as long as you like communicate, right? As long as you like are in constant communication with your users and like you tell them you're going to break. I think the worst thing is when you don't tell your users that you're going to break them and they're surprised.
Mm-hmm.
As a user, that's super irritating, right? That's so frustrating. So I think like it is a product of maturity. Like, and as PyTorch became more and more used by production, not only inside like Meta, but like and in the world, like you can't just break production users, like, because they've taken a bet on you implicitly, and you know their products. And I remember when Microsoft like made a bet on PyTorch, and you know they obviously have Onyx and they still use Onyx today, but they made this huge bet on it. And you know, to be a $2 trillion company taking a bet on a framework that another company is building, that was a huge leap of faith from Microsoft. I mean, OpenAI as well, when they took a bet on PyTorch with us. And you know, I remember meeting with David Llama and the team in San Francisco, and they're like, "Yep, we're betting on PyTorch." And like, obviously, they built GPT-3 on it and GPT-4, and you know, so it's like, you know, it's a leap of faith at the end of the day, and so like, ultimately, you have to think not only about your needs and what your company needs, but also like what the community needs, and that forces you to think a little bit different and take different risks, or push some of the entropy into like repos that are outside of the core, where you can kind of figure things out. Because we spent a lot of time with PyTorch, like modularizing the code base, and it's still to this day. We spend a lot of time basically every time we think about a new paradigm or a new API or something. It sits outside the core. We can understand whether there's value. We can graduate it. If we see that we want to support it long term. But ultimately, like, people now are so relying on PyTorch. It's, breaking them is so hard, right? It's not, you need to be thoughtful about it. And so, processes evolve, right? We learn how to deal with it. And the community adapts to it, and they come to expect, okay, well, I got a warning. Aha, I better change my code because next release, right? Things are going to change, and people do it. So,
were there other like major differences in culture that you really feel like? What is it like to be working at Meta versus working at Google on these big open source projects?
I mean, culturally, I can tell you, in terms of open source, they're very different. Say, at Google, it was more of a question of open source on something, like as in, okay, we built this thing, like, maybe after the fact, like, should we open source it? I don't know, maybe I don't know, it's gonna be hard. Let's align like a bunch of VPs because, no one agrees on what to do. Whereas Meta, I think the going assumption for just about everything is that it's going to be open source, or we will think about open sourcing it. Now let's talk about, number one, our goals. Number two, like what success looks like. What kind of a community should we build? Like what, how would we license it based on our goals? So it's kind of like a built-in assumption here that we're going to be open about a lot of our technology. Whereas like that assumption at Google, in my experience anyway, and this is just my, time there, is that it's not an assumption that things will be open. It's, it definitely, it was harder, right? And it's just a cultural difference, I think, that in the companies, and how they view these things. Again, just probably my experience in a lot of ways, but it was a lot harder. Open source was a lot harder there. And I think the other thing that was different that I found is, and this is more of an ethos that I've adopted over the years, is, if you're going to open source something, you absolutely need to support it, and you need the team that's developing it to be there to support it. And I'm not saying Llama is perfect. Believe me, we're fixing issues as quickly as we can, and we're trying to support the community as best we can. But we do have processes, right? We have weekly triage meetings that I've been running, and then in that, I think Google was a little bit different. I think in certain parts of it had that level of empathy. Like I loved, for example, the tensor board team, like Nick Felt and those folks over there. We partnered so closely with them on PyTorch because, we were thinking about, hey, we need a really nice like visualization tool. Like TensorBoard was like becoming the standard. Like how do we remove the TensorFlow dependency and support PyTorch, because we don't really want to build something brand new. And I remember we removed the TF dependency and then basically got it so you could just basically import it into PyTorch, like with a single line of code. It was so awesome. I remember I brought over like half a dozen bottles of scotch over to Mountain View, gave them out to the folks over there that landed the PRs, and we were all like, having a drink, and it was so cool. That team is great. Other parts, like they've struggled, right? They they have internal priorities that are overriding support externally, or they don't prioritize it or whatever. So it's definitely like, it's a little harder over there than I think it is at Meta.
Makes sense. You didn't give us any scotch when we integrated with you. We begged to integrate with you.
I'm glad to buy you a glass of scotch, or a bottle. That's cool. Either way.
No worries.
We can share a bottle.
All right. I'm looking forward to that. Did you want to talk about the AI Learning Alliance? I saw that you're the co-founder of that, and I was curious to know like how you think about that and what it does.
Yeah, this is another reason I'm excited to be back here. This is such an amazing team. It's like Mark Tigert and Paco Guzman and Diamond. Like it's just such a cool team, and there's such so I'm of the belief, maybe this is because I married a Canadian, but I believe education is the root of everything. And I don't think that's exactly a controversial statement, but like I really believe in education. I really believe that if we had better education, it would solve a lot of our challenges. And I think one of the things that I love, I spent several years teaching and building things for the Georgia Tech collaboration. I think education should be open. I love open courseware. I love, for example, like all the Stanford stuff that Chris Manning has released over the years. With obviously the bonus that is all built on PyTorch, which was super cool. But I think open courseware and just being transparent and helping to just lower the barrier to entry and just level the playing field. And that was really what ILA was about. That's really what the AI Learning Alliance was about. It was like, we taught this class, this master's level deep learning course at Georgia Tech for several semesters. And, then we basically released all of the course materials, including, notebooks, and code and lecture notes and slides and everything. And then, really helping to focus on, for example, like historically Black universities, historically Hispanic universities, global universities, anyone honestly who would work with us. I mean, we really wanted to kind of scale it because like, I think we're in a bit of a bubble here. The universities that I've worked with so much in the past I have such a West Coast bias just because it's so easy for me to work. I can drive to Berkeley, I can work with the professors and the students there, or Stanford is, 20 minutes from my house, or NYU, obviously, because, we have Llama2 and our team in New York. And we have such a bias towards these, I'll call them convenient schools because they're so close to us, or we just have strong ties to them. But like, there are so many, there's dozens, if not hundreds of universities globally that want to be able to teach machine learning and AI. And, and they need basic materials to be able to do it and help train the trainer and help teach and help grow this and help, kind of foster, I would say, like the next generation of professors, not at top tier schools, but at these other, at any school, frankly, because machine learning, I think, is so important. So yeah, I'm very proud of that work. I've spent a lot of time in my career building courses. I try and do everything in the open. Andrew Trask, if you know Andrew over at Google, and he's a DeepMind. He founded the Open Mind community, which is still to this day like amazing to me and an amazing feat. He built it all around the premise of privacy and basically keeping data private, but still kind of innovating on that data. And he calls it kind of working on data that you can't see. And so we built a lot of tools together on PyTorch. We built classes together. We released those on Udacity and other platforms. And I just firmly believe that if you can, lower the barriers and you can help educate people, it's so important. So that's where I stand.
That's cool. I know from reading the comments and the reviews of this podcast, we get a lot of people interested in learning more about machine learning. Do you have any pointers to where you'd send people today? I mean, the problem is, one thing about the space is the shelf life is so short on a lot of this content. I mean, even the stuff, we put out 2 years ago feels like it's definitely like, not up to date. Like we're here, it's November 2023. What are the best resources according to Joe?
I like the Andrew Ng courses, the ones that are like 2 hours long are, super interesting.
This is the new like deep learning.ai.
Yeah, I think they're really cool. I think we're our attention spans are getting shorter. Our time is getting shorter. We're getting busier. I think that couple that with, to your point, the space is moving ultra fast, and like new libraries are getting created and getting popular, like at speeds we've never seen before. And so I think I really love what Andrew's done with the deep learning AI courses. I think I saw the one with Harrison and Langchain, and I thought that was really cool. And then the one with Sharon and the Lamini folks. So I think you can those are really good. I think there's also no substitute for kind of learning the nuts and bolts as well. I think if you look at the 60-minute blitz on PyTorch that Sumit put together several years ago, that's still incredibly popular. People go to it and use it, and I know, I guess CNNs aren't really exciting anymore, but building a CNN from scratch is still fun. And building, an image classifier is still fun, or building, and it's still kind of, and it's not just fun, it kind of gives you really an understanding of how this stuff actually works at the end of the day. Versus for better or for worse, the barriers to interacting with Gen AI are so low. So people, largely my parents, for example, or people who are new to ML, they interact with ChatGPT or Bard or these things, they prompt things, and they don't really understand what's happening underneath, that there's a large model and you're interacting with it, and there's all these gem operations that are ultimately being run, and forwards and backward propagations and updates and all these things, and how these models are constructed and how inference works, and I think actually going back to basics. And actually, I remember, writing my first network all in NumPy, for example, was really cool. This was a long time ago now. And I just learning, relearning the chain rule, right? But writing it in NumPy and Python, because obviously I was in engineering and undergrad, and I learned the chain rule ages ago, and then probably forgot it and then relearned it. And so I think that it doesn't hurt, I think, to go and just learn these things and understand how these models actually work. And versus honestly, like if you just interact with them at like the surface layer, while it's cool and it kind of democratizes things and it makes it more of an interaction, you're really like kind of clueless as to what's happening underneath. So
yeah, I totally agree. I learned a lot from implementing many things in NumPy myself. That's been an important part of my process. Well, all right. I feel like we should wrap up, and we always end with 2 questions that feel free to take in any direction you like. But the second to last question is, what do you think is an underrated topic in this broad field of machine learning and the LLMs that you work on?
I'm going to go with, I'm still going to stick with AI for science. I spent a bunch of time on that previous to Google. And, if you look at some of the teams that were in my, some of the projects that were in my team, like the theorem proving and our protein team, which is, now in kind of building a business. And there's a team still there that's, working on Open Catalyst and now they just released a data set for direct air capture for carbon removal. And this isn't, LLM specific, these are actually GNNs. But obviously just, I would say in ML in general, I still love to see the direct impact of work. And you know what I mean? It's like, if this is when we were selling, for example, the direct air capture project last year, we met with Shref and we met with leadership and we're like, hey, we want to build this thing and we want our data centers, we want to build into our data centers. We want to basically open source everything so we can create a community, and we don't want to keep this technology to ourselves because frankly, we want to have global impact if we possibly can. So those are the kind of project, that's where I see so much potential, and there's just very little, everyone is kind of looking over there when all that's happening over here, right? Everyone's focused on chatbots and being able to generate images and videos, whereas I really think the impact is actually in the more pragmatic sciences, in areas like biology and material science. And so ultimately, I can see direct impact from that research. It's not it's far off. That's what honestly excites me.
I totally agree with you on that, and feel the same way. But I actually hadn't heard of this air capture project. Can you tell how does machine learning help with that?
Yeah, I mean, if you look at, so I'll just talk about Open Catalyst for a second. So Open Catalyst is a project that has been going on for a couple of years. So Larry Zitnik is the researcher in FAIR that, this has been his, he was actually in computer vision at MSR for a long time. So he's a long time, Microsoft guy, and he came over and one of the early FAIR researchers. And, up in one day, he basically learned chemistry and just started bridging, ML and chemistry and started this project. And he's an incredible person. You should probably have him on this podcast. He's one of the folks that is really, really interesting to talk to. So I'll send him your way.
Please.
And, what we learned is that, you can take this same paradigm of kind of exploring, the materials and kind of molecules much more efficiently, using, say, graph neural networks. And so you kind of you have, Schrodinger's equations, and you can go and solve those and do this the hard way, right? You can estimate that using something called density functional theory, DFT, and then you can actually estimate GFT with an actual GNN, and you can get it to be really pretty accurate enough, basically such that you can actually use it as essentially a really amazing filter that gets you to some interesting molecules, even generate frankly materials that have never really been explored before. And we have internal projects where this has actually landed real impact. We've and even in terms of the Open Catalyst project, where the whole goal of that project is basically to find a low cost catalyst, right? So today it's platinum and these very expensive materials. If you find these things that are cheaper, you can actually lower the barriers to lower the cost to generating things like green hydrogen, and that's really the premise of that project. And so what we essentially thought of is when we start to look at these other material regimes, if we look at areas say sorbent materials and direct air capture. So if anyone's familiar with direct air capture, you take in the air, you capture the CO2 in a sorbent, and then you have to regenerate that sorbent, which basically removes the carbon from it, and then you can do something with the carbon, like sequester it under the ground, turn it into some type of a biofuel, whatever you want to do with it. And what we found in just working with this community is like these sorbent materials, to regenerate them, actually in some cases, like in liquid, and my knowledge is a little bit out of date here because I've been working on Gen AI too much. But you have to heat the sorbent up quite a bit in order to, like, we're talking liquid in hundreds of Celsius. Like, I think at some point it was something like 900 C to regenerate a liquid sorbent. That's probably lower now because I'm sure there's been some innovation in the last year, but that's really expensive, and you might actually generate more carbon as a result than you've actually captured, which makes it kind of a futile process. And so the goal of that project is ultimately, to explore different material spaces and find sorbents that, could even, for example, like run off the waste heat of, say, a data center or a building, or, something where you don't actually have to expel a bunch of energy just to remove the carbon. And so, if you can find the right materials that kind of can operate within certain climates, because obviously desert versus, say Iceland versus, northern Canada, these are very different climates. And the sorbent may be different for each of those climates. So it's not something that you can just solve and be done. And so that's really where being able to explore a lot of different, molecules and materials is really interesting. So so it's a really interesting space. Anima
Totally.
Kumar at NVIDIA is also like working on some of these things, and she's applying a lot of it as well. So if you want to talk to her about that.
Yeah, definitely. I love that stuff. But all right, we should get to our final question, which I'm sure you'll have an interesting perspective on, which is when people try to get these things to work in the real world, and normally ask like generally like models in the real world, but I'm curious for you, when people try to get like Llama2 to work in the real world, what are the biggest issues that they run into today?
I think it's actually pretty straightforward to kind of get a proof of concept these days with these models. I think the barriers are so low. Like you can, even these APIs, for example, we have fine tuning APIs. Like you go to like Together AI, you can grab Llama models and you can do like supervised fine tuning on them and be able to deploy for an application pretty quickly. I think the biggest barriers in my mind to open models though is, if you want to take a model besides say like the canonical models that say like we release, and like I said, there's like 11,000 of them on Hugging Face, and I'm sure like probably double that or at least that amount in private hosting. You don't know the data lineage, and I think that's like, so you don't know like what exposure you have, for example, there. There's also I think evals are still a problem, I think, for safety, and I think you saw like I think Scale released their safety suite this past week, which is pretty cool. But I think like we still have a long way to go in terms of like taking these models and actually, today I think there's pretty basic stuff. Like I think OpenAI has a content moderation API. They also have a copyright infringement API they just released. And I think these are great starts. But I think that's like the biggest, like some of the biggest challenges, because inherently these models are risky. Like there's risk to them. And I think we need to build a lot more safety and responsibility into the system. And like I said, I want to do that in an open way as much as possible. So I would say those are probably the biggest things. But also like, it's much easier to use an API than it is to use a Llama model. And that's why, we're glad to have our partners. Like not every company can take a model, a set of model weights, and then be able to deploy a 70 billion parameter model at like scale, right? LLM ops is a thing. And it takes effort and it takes engineering and it takes some know-how to do it efficiently. Like you probably get it to work, but that's why you see like these articles that say, hey, I'm spending way too much on my open source model deployment than I am with some like API, is because there's some work to be done, right, to do it efficiently. And I think I'll be investing to kind of lower those barriers over time. But ultimately, but today it's still hard for many companies. So,
awesome. Well, thanks, Joe. This is super fun. Really appreciate it.
This was fun.
Good to catch up.
All right.
Yeah.
So I think
I
owe you some scotch. So let's get together and get a glass of scotch.
Let's do it. Yeah, that sounds great. Thanks so much for listening to this episode of Gradient Dissent. Please stay tuned for future episodes.